Hi friends, welcome to our session Raju's gas chromatography. Today we will discuss about development of gas chromatography. During the development of gas chromatography, we need to consider 4 points. That one is quantification of analytes, second one is selection of technique, third one is effect of sample matrix, and fourth one is selection of stationary phase. During development, we will discuss these 4 chapters one by one. The first one is quantification of analytes, second one is selection of technique, third one is effect of sample matrix, and fourth one is selection of stationary phase. We will discuss one by one. During the development of gas chromatography, what type of steps involved? The first one is quantification of analytes. During the manufacturing of drug substance, during the synthesis of drug substance, the CRD team might be used some of solvents like methanol, ethanol, IPA, toluene, heptanes, hexanes, DMAC, NMP, DMF. These I have written for given general information only. Whenever we are quantifying by GC these solvents, we need to show the options or control as per regulatory requirement. Along with this one, what are the possible contaminants it will form during the manufacturing process from this solvent? That also very important. For example, these we can consider as a process solvents. Now it comes to process contaminants or possible contaminants. Here possible contaminant we can consider like benzene, because manufacturing of ethanol, IPA, toluene, that benzene might be present. After completion of drug substance, along with the solvents, compulsory we need to show the options of benzene in drug substance as per regulatory requirement. Further, we need to quantify process degrades. Here process degrades might be you come ethyl chloride, MMS, EMS means methyl sulfonate, ethyl methyl sulfonate, another one para-toluene sulfonate and ethyl para-toluene sulfonate. These two comes under tosalates. These two comes under methylates. These two comes under potential genotoxic impurities. How it will form these process degradients, I will inform in next sessions. During the reaction, how it will come methyl chloride, ethyl chloride, MS, EMS, what are the level we need to quantify as per regulatory requirement. I will discuss. Now just I will giving information in this session only. Now it comes to second one, selection of technique. The selection of technique in GC, the most important. The selection of technique we can divide into 2 parts. One is headspace, one is liquid injection. In headspace, all members are know how to prepare headspace section, how to know in liquefaction how to prepare the sample. In headspace, simply we'll take the drug substance, we'll transfer into headspace where we add 1 ml or 5 ml of suitable solvent, then incubate that vapor, it will go to GC column through transfer line. This is a simple technique in headspace. When it comes to liquid, the drug substance will dissolve in suitable solvent and transfer into 2 ml vial and we inject through syringe or 10 microliter or 5 microliter. That vapor, it will go to column in desired temperature what we are kept in injector port. This is the two technique difference. Now it comes to quantify these solvents, how to distinguish in a selection of technique. One is headspace, one is liquid. Because whenever we are performing the headspace technique, we need to consider here also 3 points. Just I will write simply. One is the analyte should have volatile nature, because without volatile nature we cannot analyze on GC. And next one is we need to consider low boiling point. And third one is low molecular weight of these 3 points should we need to consider during the GC analysis. First one is analyte should have volatile nature, second one is low boiling point, third one is low molecular weight. These 3 are very important. Now it comes to technique wise. What are these solvents? Because for example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. These 17 solvents we cannot analyze a single method. Okay, because we need to categorize 2 methods, depends upon volatile nature, depends upon molecular weight, depends upon boiling point. If you will write, generally by headspace we can analyze these solvents. What are the low boiling point, easily volatile, that compounds we can analyze by headspace. For example, in headspace we can write what solvent type of solvents we can analyze. Ethanol we can analyze, ethanol we can analyze, IPA I can analyze, toluene, heptanes, hexanes, and methyl chloride, ethyl chloride. DMF also we can analyze. If it comes to liquid, TMAC, NMP, DMF, MMS, EMS, methyl para-toluene sulfonate, ethyl para-toluene sulfonate. Because these are having boiling points as high as comparatively these solvents, because these solvents might be have below 150 degrees of boiling point. These have above 150 degrees. Because why we cannot analyze on headspace? These are volatile nature is less as comparatively this solvent. That's why we are choosing in a selection of technique 2 categories. One is liquid, one is headspace, one is liquid and one is headspace. Depends on analyte volatile nature and boiling point and molecular.